All right, guys, today we're talking about volume, okay? So just by way of review, a flat measurement, a straight measurement, oops, going crazy. So there's 1 inch, okay, this is a unit measurement, just a straight measurement. Now, that would be to measure like the distance across something. And then that's like if we were measuring, for example, the length of something, perimeter, anything like that, we would use a straight unit measurement like that, just a unit segment. Okay. Now, if we were measuring area, we would do, move my paper here a little bit. I'm just going to estimate the other parts. A square unit. So this is 1 square inch. So we write it like that. And we use that measurement when we are finding area because we're figuring out how much space something takes up. Okay. Then finally, what we're going to talk about today is volume. Volume is a cubic measurement. So with area, we're looking at how many, for example, 1 inch squares could you lay across something to fill that space. With volume, I'm thinking about how many cubic inches or cubic centimeters or cubic whatever you could fit inside your space, okay, that I would use to fill this. So a cubic inch, and I'm going to do my best to estimate one here, it would be a cube that's shaped like this. Okay, and we would write this as 1 cubic inch, a little 3 right there. And we use cubic measurements when we're talking about volume. So this is all at the top of page 671 in your text is where I'm looking at, okay? So when you want to know how much space the object occupies, or I like to think of it if you filled it with water or if you filled it with bricks, how many would you fit? Then you're talking about volume. So it's got to be a space figure. It can't be just a flat drawing on a page. It's got to be something that's 3-dimensional. Okay. So if we look at example 1 in our text, it says, give an example of a unit that might be used to measure these different things. So for letter A, the amount of molding around a room. That's like the trim on the floor around your room. What do you think you would use? A straight measurement, a square measurement, or a cubic measurement? You would use a straight measurement because you're measuring distance here. Sorry, I got distracted because I was thinking about how I wanted to write it down. Okay, so for letter A, you would use just inches to measure that. Well, probably feet, but still. It'd be a straight measurement, a unit measurement. Letter B, I guess I should say feet because that inches would be ridiculous. All right, letter B, the amount of carpet on the floor of a room. Well, for that, you would be using area here because you'd be measuring the space on the floor and figuring out how much carpeting you needed to fill it. So we would be using square feet in that example. And then for letter C, the maximum storage capacity of a room. That's like if you have a storage unit, you're going to fill it with stuff. How much space is inside that storage unit? Well, now we're talking about volume. We're talking about a cubic measurement. So we would be talking about cubic feet. Like that is how we would write that. All right. Okay, so let's look then at below example 1 where it says to find the volume of an object. Okay, so basically what you're doing is you're counting up how many cubes would fit inside this. So if you look at the bottom of page 671, you see how there is a box over to the right. It is 2 inches by 2 inches by 2 inches. So how many 1 inch cubes would it take to build that box? If you're not sure what I'm talking about this box right here. So how many of these would it take to build this? That's volume. So if we look here, we can see there are 1, 2, 3, 4 in the front, and then there are another 4 in the back. So it would take 8 cubic inch blocks to build this. So we would say that the volume of that box is 8 cubic inches. Okay. And then if we look at example 2, we're doing the same thing here. In example 2, if we take a look at that one, we have a box, and I'm going to sketch it here. Very messy sketch. But it's 2 centimeters by 3 centimeters by 2 centimeters, okay? So it looks like this, and then along the back. There we go. All right, don't feel like you have to sketch it. To count up how many cubes are in here. There are 1, 2, 3, there's 4 in the front, and then there's another layer of 4 and another layer of 4. So 4 plus 4 plus 4 is 12. So I could say that the volume of this box is 12 cubic centimeters. So one way is to count them. But thankfully there's another way, because you're not always going to be able to count them. Like if I asked you to tell me the volume of this box, well, there's no cubes marked off on it. So you can't just simply count the cubes. But there is another way to find the volume. We can use multiplication. Okay? We're going to kind of skip over example 3, by the way. Not because it's not good, but I just chose not to do it with you. So our formula is that volume equals length times width times height. Now remember, I use a cursive L to show length in math. Your book uses a print L, but I have issues with that because it looks like a 1, and that's confusing. So we're going to use a cursive L. So to find the volume of this box, we would do 2 times 3 times 2. And so 2 times 3 is 6, and then we can bring down this times 2, and 6 times 2 is 12. Look at that, we got the same answer. Okay, so to find volume of a rectangular solid, we do length times width times height. That is our big thing to remember. We do length times width times height. So let's look over at example 4. Actually, I better start a new video to make sure I don't run out of space. Go on to the second video.